Hey guys, so today we're going to be looking at your Unit 5 review, which is over systems of equations and inequalities. So let's go ahead and get started. Number one, what we're looking at is the comparative cost for lawn services at Lawn Care and Glory Gardens in terms of acres, and it's shown on the table. So the thing that we have to remember with a table is that we are going to be plugging it into Desmos. But before we can do that, we have to split this table up. So number of acres is going to be consistent in this equation. So for part A, we need to determine representative linear functions for lawn care and Glory Gardens relating costs C in terms of acres A. So we have to understand which of these is going to be X and which of these is going to be Y. And if we remember, cost is always going to be Y. And then the number of something is X. Oops. So what we're going to do is, again, we have our number of acres, X. Lawn care, we're going to label this as Y1 because we're going to calculate it first. And then Glory Gardens is going to be Y2 because we will calculate it second. And we're going to be using Desmos to help us figure out these equations. So again, use Desmos. Okay, so let's go ahead and enter these in. Let me fix my screen so I can see everything. So if we remember to add this into Desmos, we need to create or add a table. And I'm going to type in the number of acres. So we have 0.25, 0.5, 7.5, 1, and 1.25. Once you get a couple of decimals in, Desmos figures out the rest for you. And we're going to calculate lawn care first. So the prices here, we have $43.75, $62.50, $81.25, $100, and then $118.75. The next thing we have to do is type in our equation, which is y1 squiggle mx1 plus b. And if you forget this equation, it is, at least in my room, on an anchor chart. And the two things that we need from this, or these answers, is your m and b. So we need m and b. And I'm going to come over here and write my equation, and we need to remember that we are writing this equation using C and A instead of Y and X. So the total cost for lawn care equals 75x plus 25. That's our first equation. So what I need to do now is go back and just change these numbers. I just have to change my y values. So let's go ahead and do that. We have 65, 80, 90, 110, and 125. And that gives us a new set of values. And so for this one, C equals 60x plus 49. And those are our two equations given the information in the table. So for part B, it's asking us to graph each representative function on the same coordinate plane. All right, so what we're going to do is, for this graph, we need to label it. So to label this graph, of course, we start with 0. 0 is always at the corner. And I'm going to count by tens. Or we're going to count by fives. So 5, and again, I keep touching buttons on my iPad, sorry. So 5, 10, 20, 25, 5, 40, 45, 50. And then because the number of acres is in decimals, I'm going to count by I'm going to count by 0.25. And you can keep labeling the graph if you would like, but we are not going to use that. So what I'm going to do is just take points from this table and graph it. And this is going to be an estimation because, again, you will not have to graph these by hand, especially since some of these numbers are really large. So for the first one, we have 0.25 and 43.75. Well, sorry guys, we're going to look at the graph. So the first equation that we typed out was, remember we have to convert this back to y and x, so y equals 75x plus 25. So I'm going to zoom in on this graph so I can see the true numbers. And your y-intercept is at 25. My y-intercept's at 25. So that's the starting rate. And then we just need to find other points on this graph. So another point we could use is 0.25 and 43.75. So it's about right here. Okay. For the second graph, we're starting at 49. And this one is going to continue to go up as well. So let's go ahead and look at part C. So use the graph to determine the number of acres for which the cost is the same at both companies. And we can label the point on the graph if we needed to, but let's go ahead and look at Desmos. So in Desmos, I need to go ahead and graph the second equation. So y equals 60x plus 49. And we're looking to see where these two graphs cross. I have a feeling it's going to be somewhere in this area, but we'll see. So I'm going to zoom out. And again, it's kind of hard to see because these graphs are so close together. Oh, right here. So the two graphs intersect at 1.6, comma 45. So what this tells me is that at 1.6 acres, the cost for both companies will be $145. Yeah, $145. So this one was kind of more difficult to see because we're dealing with such weird numbers, but it won't always be like this. So again, at 1.6 acres, the cost will be $145. If I would have labeled my graph a little bit differently, then it would have been easier to see. All right, so let's go ahead and look at question number 2. So for this one, we also have another multi-part question. And it says Janice spent $130 on 40 chocolate truffles to serve at a baby shower. The cherry center truffles cost $2.50 each, and the caramel centered ones cost $3.75 each. We need to determine two linear equations and two variables to represent the problem situation. So first thing we need to figure out is what are the two situations we have going on here. And if you look at the first sentence, I always try to look for totals. So for the first sentence, we have a total cost. So we have a total cost and a total number of truffles. So I'm just going to make a note of that. So total cost, and that was 130. And then total chocolates are 40. So that are the two things that we can identify here. The next thing we need to label is our variables. I'm just going to use X and Y. So we have two different kinds of truffles. We have the cherry ones and the caramel ones. So the first thing we need to realize is that they don't tell me how many cherry truffles I order, and they don't tell me how many caramel ones I order. So what we have to do is just create an equation, adding them together. So X plus, sorry guys. So X plus Y equals 40, because that is the total number of truffles we ordered. Okay. Next thing we need to look at is the total cost. So cherry truffles cost $2.50 each. So 2.5x plus caramel ones cost $3.75. So 3.75y equals 130. And that is the two equations we can create for this scenario. Part B is asking us to solve them and figure out how many did she purchase of each. So let's go ahead and solve these and then we'll type them into Desmos. So the first equation we have is x plus y equals 40. And what we need to do is subtract the x from both sides. When we subtract x, y equals 40 minus x. So this equation is good to go. We can go ahead and type it in Desmos. But let's go ahead and solve the other equation. So 2.5x plus 375 y equals 130. So again, we're going to start off by subtracting 2.5x. This cancels and we're left with 375 y equals 130 minus 2.5x. The last thing we need to do to solve this equation is divide. So I'm just going to divide everything by 375. And since these are not the prettiest numbers, I'm going to leave the right side as just one big fraction. So y equals 130 minus 2.5x over 375. And now that we have both equations solved, we can go ahead and type this into Desmos. So the first equation we had was y equals 40 minus x. The second equation we have is y equals, I'm going to type in my fraction bar first. So 130 minus 2.5x over 375. So what we need to do is zoom out on this graph so we can kind of see where everything starts. And this one is a little bit easier to read than the first one. And I can clearly see where the intersection point is. So if you just click on the graph, and right there, our graph intersects at 16, 24. And what this tells me is that she purchased 16 cherry truffles and 24 caramel. So 16 cherry truffles, 24 caramel truffles. And this would be our answer. All right. So I get number 3. So number 3, we have two linear functions that are represented on the graph. And what we need to do is write a system of two linear equations for y1 and y2. So we just need to write their equations. And we already know how to do this. If I can find 2 points on this graph, then I can plug it into Desmos and find their equations. So let's look at, we'll make this line y1 and this line y2. So let's look at y1 first, and I'm going to find 2 points on this graph. The first one we can choose is at, so for y1, we have 0, -1. And then another point that we can use, of course, the intersection, is at 1, 4. So let's take those 2 points, go to Desmos, and find the equation. We add a table, and I have 0, -1, 1, 4. And the next thing we need to do is type in our lovely equation y1 squiggle mx1 plus b. Oops. And right here, my first equation is going to be y equals 5x minus 1. So that's our first equation. Now what I need to do is find 2 more points for the second graph, so for y2. So for the second graph, again, I can choose the y-intercept, which is at 0, 7, and our intersection point, which is at 1, 4. So when in doubt, choose the intersection. So let's go over here and change this point to 7. And we can see that our equation is going to be y equals negative 3x plus 7. And those are our 2 equations for this graph. So let's look at part B. Determine the solution to the system of the linear equations if it exists. And for this one, we already figured out what it was. The solution is at 1, 4. Okay, let's look at the next question. So question 4, we need to graph each system of linear equations on the coordinate plane and determine the solution if it exists. So we're going to be doing a lot of solving and graphing for this one. So the main thing that we need to do is make sure that all of these equations are solved for y. And if you look at part A, this equation is not solved. So let's go ahead and do that, then we'll graph. So 2x plus 3y equals 12. I'm going to start off by subtracting 2x from both sides. And we get 3y equals 12 minus 2x. Last thing we need to do is divide by 3. And y equals 4 minus 2/3 x. So that's the first equation. The second equation we have is 4x minus y equals 10. So we start off by subtracting 4x. And we get negative y equals 10 minus 4x. The last thing we need to do is make sure that we understand that this is a negative 1. So I'm going to divide everything by negative 1. And all that does is flip the signs. So y equals negative 10 plus 4x. So let's go ahead and graph both of these equations in Desmos. The first equation we have is 4 minus 2/3 x. The second equation we have is negative 10 plus 4x. You don't have to type the y equals if you don't want to. You can still type it in the right side of the equation. So what I'm going to be doing from here is just grabbing key pieces of information. So let's look at the y-intercept. So the purple line, I'll mimic the colors too. Purple line we have at 0, 4. X-intercept we can see is at 6, 0. And we're going to go ahead and graph the intersection point. It is through 3, 2. And then I'm just going to connect those dots to create the line. Close enough. Okay, let's look at the second line. So for the black line, we have an X, well, I've technically graphed my y-intercept at 0, negative 10. Then my x-intercept is at 2.5. And then they share 3, 2. So I'm going to go ahead and draw this line. And there we go. The solution for this one is at 3, 2. All right, let's go ahead and look at the second set of equations. So for this one, we're starting off with 4x minus 5y equals negative 25. I'm going to subtract 4x from both sides. This gives us negative 5y equals negative 25 minus 4x. The last thing we need to do is divide by negative 5. And y equals 5 plus 4/5 x. Okay. This second equation we have is going to be 10y plus 30 equals 8x. This one is a little bit different in the way that it's written, but the steps are still going to be the same. The first thing I need to do is either add or subtract the 30 because it's on the wrong side. Sorry about that, guys. So again, like I was saying, 10y plus 30 equals 8x. We need to subtract the 30 from both sides because that term is on the wrong side. 10y equals 8x minus 30. And then we are going to divide by 10. And that leaves us with y equals 8 over 10 will reduce to 4 over 5. X minus 3. So if you look at both of these equations, we have the same y-intercept. So the same y-intercept, we have the same slope. And we have different y-intercepts. So technically we could determine what the solution is without even having to graph it, but let's go ahead and look and see what this graph looks like. So if we go to Desmos, we have y equals 4/5 x minus 3, and y equals 5 plus 4/5 x. So again, if they have the same slope, different y-intercept, this means we're going to have parallel lines. Let's go ahead and graph it, and then we'll talk about their solution. So for the blue line, we are starting at 5, and so we graph the y-intercept at positive 5. Another point that I could use on this graph right here at -5, +1. Another way that you can get the points on the graph is if we go to settings, and you can change both of these into a table to kind of see what some of the points are. And if you want to add more points, just make sure that you press enter and it'll add more for you. And I believe we use -5, +1. Okay, for the second line, oh, sorry, I forgot to draw the line. That might help. So there we go. Kind of what it looks like. And then for the second graph, we're starting at 0, -3. And I'm going to add more points to this to see what's another one we can have is at 5, +1, +5, +5, +1, and then connect the dots. So if we remember, parallel lines never touch, cross, or intersect. So this one has no solution. Okay. Let's look at the last graph. So the last graph, we don't have to do too much work. So for the first equation, I have 3x equals 14 minus 7y. I don't like where the y is at, so what I'm going to do is just kind of flip this equation. So I'm going to write it as 14 minus 7y equals 3x. And now it's a little bit more comfortable to look at. So I'm going to start off by subtracting 14 from both sides. And we get, oops, this zeroes out, and -7y equals 3x minus 14. And the last thing we have to do is divide by -7. Oops, sorry guys, I didn't realize it had scrolled. So when we divide by -7, we're left with y equals -3/7 x plus 2. Let's go ahead and solve that second equation, and then we'll look at both of them. Sorry guys, my hand keeps touching buttons on my iPad. So the second equation we have is 28y equals negative 12x plus 56. And we're going to divide by 28. So y equals, and let's go to Desmos and figure out these numbers. So we have negative 12 divided by 28. I want to change that into a fraction, and we get negative 3/7. And then 56 divided by 28 is 2, so plus 2. And if we look at both of these equations, they're the same. So we have the same slope. So again, we have the same slope, same y-intercept. Let's go ahead and graph them. Even though they're the same, let's go ahead and graph. So negative 3 divided by 7, x plus 2, y equals negative 3 divided by 7, x plus 2. Again, both of these equations are right on top of each other, which means they share an infinite amount of points. So let's go ahead and graph it. My y-intercept is at positive 2. X-intercept is about at 5-ish. About right there. So I'm just going to connect the two dots. And that looks terrible. Good enough. So that's kind of what our line would look like. And the second line would be graphed right on top of it. And what this means, again, is that they share infinite points. So it has infinite solutions. Okay. Let's look at the next set of problems. So for problem 5, Serenity has no more than 15 hours available Monday through Friday for volunteering at the animal shelter and working at her part-time job. So we're doing two different things. And she needs to spend at least twice as many hours at her part-time job compared to the shelter. And we have the inequalities graph below, or we have the inequalities here. And what we need to do is determine which graph best represents these equations. Okay, so what we need to do is graph both of these equations, but first we need to make sure that both of them are solved for y. And the second equation is good to go. Y is by itself, so I could technically go ahead and graph that one, but let's go ahead and fix that first equation. So the first thing we have to do, and only thing we have to do, is just move and subtract your x from both sides. So y is less than or equal to 15 minus x. And the inequality symbol lets me know that it's going to be a solid line shaded below. And the second equation is greater than, so this one should be shaded above. So let's go ahead and graph both of these equations. Again, all you have to do is type in the right side. So the first one we have 15 minus x. There's 15 minus x. And the second equation we have is 2x. So that is what both of these equations should look like on the graph. So the blue line, my y-intercept is at 0. So this one should be shaded above. So the blue line, we should have it shaded above. Oops. So it should look something like this. And then the red line, if we remember, is less than or equal to. So it should be shaded below. So we're looking for a graph that looks something like this, where this triangle is the one that both of them share. So if I go through and look at all of the different graphs, the one that shares this triangle is the correct answer, which is C. Okay, let's go ahead and look at problem number 6. So Farm Implements Incorporated has a bin filled with a combined total of 245 quarter-inch nuts. So we have a total of 245 quarter-inch nuts and bolts. Key thing that here is we have this and this. Each quarter-inch nut weighs 6 grams, and each bolt weighs 10. The total weight of the nuts and bolts in the bin is 2,010 grams. So we need to write a system of equations and solve it. And the two things that we're talking about here is total nuts and bolts, and the other one that we're talking about is total weight. And they don't define the variables for us, so we're going to use x and y. X represents the quarter-inch nuts. Y represents the bolts. So we don't know how many we have of each, but I know that added together, it equals 245. And then that last equation is going to be dealing with the weight. So each quarter-inch nut weighs 6 grams, so 6x plus 10y equals 2010. And those are our two equations. In part B, we're going to solve them. So the first one we have is x plus y equals 245. And all we have to do for this one is subtract x from both sides. That zeroes out. And y equals 245 minus x. the second equation, 6x plus 10y equals 2010. We're going to subtract 6x from both sides. So when we subtract 6x from both sides, we're left with 10y equals 2010 minus 6x. And the last thing we have to do is just divide everything by 10. So when we do that, y equals 201 minus, if I reduce this by 2, 3 over 5x. All right, so let's go ahead and graph them. So the first equation we have is 245 minus x. And the second equation we have is 201 minus 3/5x. We're going to have to zoom out really far on this one because we are dealing with large numbers. And I can clearly see the intersection point on this one is at 110, 135. And what that tells us is that I have 110 nuts and 135 bolts. There we go. So there is our answer for that equation. So again, if we look at the intersection point, that is where I got those two numbers from. All right, for the last and final question, Isabel receives a gift card from an online retailer for $25. She plans on using the gift card to purchase music and games. The online retailer charges 75 cents per song and $1.50 per game. And Isabel plans to purchase at least 18 items with her gift card. So we need to write a system of inequalities to represent the problem in the situation, using M to represent the number of songs and G to represent the number of games. So we have two situations again. We have total items and the total cost. So she wants her total number of items, M plus G, to be at least 18, meaning she wants her total to be greater than or equal to 18. And then the total cost, what we have to do is we have 0.75 M plus 1.5 G. And if I have a gift card, I can't really go over the cost or the total of the gift card. So less than or equal to 25. And that is our equation for both of those. So the next part of this problem asks us to graph the system of inequalities to represent the solution region for the possible songs and games she can purchase. But in order to do that, we have to solve both of these equations so we can graph them. So in order to solve both of these equations, let's go ahead and write them down. The first one we have is M plus G is greater than or equal to 18. And then the second one we have is 0.75 M plus 1.5 G less than or equal to 25. So let's go ahead and solve both of these equations. The first one, all we have to do is subtract m from both sides. Zeroes out, and g is greater than or equal to 18 minus m. So as you can see, I went ahead and graphed that first equation. Keep in mind that you do have to replace the m with x whenever we graph this in Desmos, because Desmos only knows how to deal with y and x. So that's what the first graph looks like, and we can kind of zoom in on it just to get a closer look. So let's look at the second equation and then we'll graph it as well. First thing we need to do is subtract 0.75 m from both sides. This cancels out and we're left with 1.5 g less than or equal to 25 minus 0.75 m. The last thing we need to do is divide, so I'm going to divide by 1.5. And since we're dealing with weird numbers, I'm just going to divide the entire right side by 1.5 and leave it as a fraction. So when we do this, g is less than or equal to 25 minus 0.75 m all over 1.5. And if I wanted to rewrite this using x and y, like I did for the other equation, y is less than or equal to 25 minus 0.75 x over 1.5. So now what I can do is go ahead and graph that second equation and we will look at it. All right, so type in your fraction bar first. 25 minus 0.75x over 1.5. And that's what the second graph looks like. So I can zoom in a little bit further. That way we can kind of see it a little bit more clearly. And if we wanted to, we could label our graph from 0 to 20 on both sides. That should work. So I'm labeling my graph from 0 to 20. And our intersection point, so the important part, is right here at 2.667 and 15.333. About right here on our graph. 18. So give me just a second, and this so keep in mind that the first equation we graphed was 18 minus x. So with 18 minus x, so the black line, it was greater than or equal to, so we had to graph or shade above. I had to shade above here. And then for this flatter looking line, the other one, it was less than or equal to, so we needed to shade below. So that tells me that this green area is where all of our solutions are at. So let's look at part C. So explain the relevance of points 12, 18, and 4, 12. So let's look at this. So 12, 8 is about right here. And if I look at the other graph right here, so 12, 8, and keep in mind that our shared region is right inside this triangle. So 12, 8, so 2, 4, 6, 8 is right there. So 12, 8 is a possible solution, meaning that she could purchase 12 songs. So this is a solution. She can purchase 12 songs and 8 games. However, if we look at 4, 12, so 1 or 2, 4, and then 12, this is not a possible solution.
Yeah.
All right, so back to what we were talking about. Whenever we graph these two, one is inside the triangle and one is outside. Meaning, if I look at the graph over here, 12, 8 is inside that double shaded area, but if we look at 4, 12, so again, 4, 12, it is not in the double shaded area. So the relevance of the points 12, 8 means that she can purchase 12 songs and 8 games. If you need any extra help, please email me. Talk to one of the other algebra teachers or any of the other math teachers, and I'm sure they'll be happy to help you. Your test will be either on Monday or Tuesday, and the review will be due the same day. Have a great day.